We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
Getting my feet out. Okay, I'm out. Really looks funny out there. See my glove out there, Jim.
Jimmy Boy, good idea.
Good morning, Gordo.
Yes, how are you?
How does it feel for the United States to be the new record holder?
At last, huh?
By cooperating together in these new realms of infinity.
We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
Hello and welcome. This is Michael Annis, and you're listening to episode 69 of the Space Rocket History Podcast. And now, Zonds 3, Venera 3, and Asterix. During 1965, there were several significant unmanned scientific missions launched. 3 of them will be covered in this episode. The first is Zonds 3. The Zonds program was one of 2 lunar exploration programs conducted by the Soviet Union to investigate the moon and its vicinity. The program began in 1964 and ended in 1979. The early Zonds 1 through 3 were originally designed for planetary exploration, while the latter Zonds 4 through 8 were sent on circumlunar flights. Additionally, the latter Zond vehicles were of a totally different design. They were, in fact, automated versions of the manned Soyuz spacecraft, which was first flown in 1967. Let's begin with Zond 1, which was launched toward Venus in 1964, and later that year, Zond 2, which was sent toward Mars. Neither craft operated for more than a few weeks, and their radios had failed by the time they reached their destinations. Which brings us to Zond 3. Zond 3 was intended to be launched during the 1964 Mars launch window. However, there were delays, and the launch window for a planetary encounter with Mars was lost. This forced the Soviets to change the mission of Zond 3. Instead of a planetary encounter, the mission of Zond 3 would become an engineering test of spacecraft systems. The systems needed to be tested because of the failure of Zond 1 and 2. Zond 3 was to be launched to intercept Mars's orbital path in order to determine if the equipment could successfully reach Mars. In other words, if Zond 3 was still operating when it reached the Martian orbital path, it would be, in an engineering context, the most successful Soviet interplanetary vehicle up to that time. To sum it up, the mission was an engineering test of an interplanetary spacecraft. But there was a bonus. On its way to the Martian orbital path, Zond 3 would fly by the far side of the moon, which would present an excellent photographic opportunity. Zond 3's design was typical of Soviet interplanetary spacecraft of the 1960s, with a rocket engine at one end, a central section housing spacecraft systems, and an instrument cluster at the other end. The spacecraft was equipped with a f/106mm camera and a TV system that provided automatic in-flight film processing. In addition to the imaging equipment, Zond 3 carried a magnetometer, ultraviolet and infrared spectrographs, radiation sensors, a radio telescope, and a micrometeoroid instrument. It also had an experimental ion engine. The launch vehicle for Zond 3 was a derivative of the famous R-7. To the west, it was known by the NATO reporting name SS-6 sapwood, and within the Soviet Union, it was known as Molniya 8K78. You may recall from previous episodes that the R7 was 34 meters long, 3 meters in diameter, and weighed 280 metric tons. It had 2 stages powered by rocket engines using liquid oxygen and kerosene. In the Molniya 8K78 version, a larger 3rd stage was added along with a 4th stage that was designed to fire in orbit to send the payload out of low Earth orbit to its destination. On July 18, 1965, Zond 3 was launched from the Baikonur Cosmodrome into an approximate 164 by 210 kilometer orbit around the Earth at a 64.8 degree inclination. As it left Earth, Zond passed the Moon, and on July 20th, it took 25 pictures and 3 ultraviolet scans of the far side from distances ranging between 9,200 and 12,000 kilometers over a period of 68 minutes, and later transmitted those images to Earth. The pictures revealed whole new mountain ranges, continents, and hundreds of craters, including the mountainous outer rings of the Moray Mekti. The pictures revealed a stark contrast between the near side and far side of the Moon. The near side of the Moon was dominated by so-called seas, mountain ranges, and large craters. The far side was a vast continent with hardly any seas, but it was pockmarked with small craters. The images also showed distinct features of a large ring-shaped formation near the terminator at the western outskirts. In total, the photos covered 19 million square kilometers of the lunar surface. Photo transmission by facsimile were returned to Earth from a distance of 2.2 million kilometers and were retransmitted from a distance of 31.5 million kilometers, or the distance of the orbital path of Mars, thus proving the ability of the communication system. After the images were transmitted, Zond 3 continued space exploration in a heliocentric orbit. The mission officially ended when radio contact ceased at a distance of 150 million kilometers. Although it had no specific target of exploration, Zond 3 proved to the Soviet Union and the rest of the world that its scientists were capable of building and operating an interplanetary craft and providing amazing photographs of the far side of the Moon. Now let's move on to the Venera 3 probe. Venera is a Russian word meaning Venus. It is also the name given to a series of unmanned Soviet probes that were sent to investigate the planet Venus. The first 3 probes had originally been designed to explore Mars, but they were repurposed as Venera probes to visit Venus. The first probe, Venera 1, was launched on February 12, 1961, but radio contact was lost before it flew by Venus. Thus the probe was a failure. The Soviets got much closer on their next attempt. Venera 2 was launched November 12, 1965, and in February of 1966, the probe managed to fly by Venus at a distance of 24,000 kilometers, but its instruments failed before it could send the data back to Earth. The probe eventually began orbiting the Sun. Another failure. Then there was Venera 3. Its mission was much more ambitious. Venera 3 was designed to deliver a small capsule called the entry body to soft land on the surface of Venus. The probe was to collect and send back atmospheric data during a parachute descent. The probe was manufactured by Lavokin and weighed about 960 kilograms. The manufacturer's designation for the probe was 3MV-3, where the M stood for Mars, which was the original target for the probe. The probe's entry body contained a radio communication system, scientific instruments, electrical power sources, and medallions bearing the coat of arms of the USSR. The launch vehicle was a Molniya similar to the launch vehicle of Zond 3. Venera 3 was launched on November 16, 1965 from the Baikonur Cosmodrome. The flight to Venus was mostly uneventful. During this time, Venera 3 communicated with the Earth 93 times, but communication was lost with the spacecraft just before the entry body reached the Venusian atmosphere. We do know that the probe impacted on Venus on March 1, 1966, which made it the first spacecraft to impact on the surface of another planet. But this was only a partial success because the communication systems failed before planetary data could be returned. Now let's move on to Asterix. In November 1965, France became the third nation to launch a satellite on its own, and the sixth nation to have a satellite in orbit. Of course, the first nation to launch a satellite was the Soviet Union with Sputnik 1, followed by the U.S. Explorer 1. Other countries that had satellites launched on U.S. rockets were the UK with Ariel 1, Canada with Alouette 1, and Italy with San Marco 1. Asterix 1 was originally designated A-1 as the French Army's first satellite, but it was later renamed after the popular French cartoon character Asterix. Although it had almost been called Zebulon or Zebby after a puppet from the television show The Magic Roundabout. The mission of Asterix 1 was to test the Diamant launch vehicle as well as take measurements of the ionosphere. Asterix had been developed as part of a kind of internal French space race. It was built and launched just 10 days before the FR-1 satellite was launched on an American Scout rocket. Weighing just 42 kilograms, the satellite had a distinctive striped fiberglass spinning top shape, half a meter in diameter. The black stripes were there to provide passive thermal control. As mentioned before, the launch vehicle was the Diamant. The French Diamant development was accomplished relatively quickly by using stages and systems being developed for strategic missiles. The Diamant orbital launch vehicle was created by replacing the payload of the existing Sapphire test vehicle with a new third stage. The liquid-fueled first stage was 10 meters long with a diameter of 1.4 meters and a dry weight of 14,700 kilograms. The first stage could develop a thrust of 302 kilonewtons. The liquid-fueled second stage was 4.7 meters long and had a diameter of 80 centimeters. It weighed 2,800 kilograms and developed a thrust of 120 kilonewtons. The solid-fueled third stage was 2 meters long and had a diameter of 66 centimeters. It weighed 703 kilograms and could develop a thrust of 29.4 kilonewton. Once the stages were assembled, the Diamant weighed 18,400 kilograms and was about 19 meters tall. It was capable of putting a 160-kilogram payload into low Earth orbit. Asterix was successfully launched on November 26, 1965, from the French launch site in Algeria. It was inserted into an elliptical orbit with a perigee of 527 kilometers and an apogee of 1,697 kilometers. Its orbital period was 107.5 minutes. Unfortunately, the satellite transmitted for just 2 days, and some of my sources said it did not transmit at all. Nevertheless, France proved that it could launch a satellite and the Diamant launch vehicle would work. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.